Let's try and do some 3D printing using some mathematical functions. So if we go to Autocad, Manage, and we're going to choose the Visual Lisp editor that allows us to create functions. This function's just been copied and pasted in after File New. It's been tested using the Load Active window. That'll give us errors if there's a syntax error. We then want to add in .3D plot, and we can just drag it into our workspace. And you double check it to make sure that it's there. And you can see that it's been loaded through the command line. When that's been loaded, we want to enact the Lisp function so that we're actually going to call this value here as the name, and then we're going to put parameters in to give it the size. So this will be the function to give us the surface that we want, and we're going to give it an X and a Y starting and finish size. So here we've got the function itself. Here we're starting at -1 to 1 with a 0.1 resolution and a -1 to 1 and a 0.1 resolution in the Y. We'll just make that 0.2. This is going to make a 2 by 2 millimeter representation of the function. So it's been created down on the 0, 0 of the XY. We can now look at that. And if you get a scale where you can't see it, you can type in zoom and then give it an all factor. That will zoom in your mesh. You can change the way that your mesh looks. Hit 3D orbit, left mouse, middle mouse pans, and it also zooms in. Now at the moment this has been created as a mesh, so it has no thickness, so it cannot be 3D printed because it only has a single surface side. If we choose the elements on here and go to properties, we can see that it's called a polyface mesh. We can give a function where we can select the mesh and type in 3dp thicken. Already got it selected, so we'll hit enter. And we'll just leave the default thickness as 0.02, which will give us a nominal 3D solid that we can now interact with. What we'll do is we'll explode this. Now treats these as a 3D surface. These surfaces can now be made into a solid using the extrude command. Now they will want to extrude themselves along their normals. Their normals are 90 degrees to the face. So we want to change this and type D for direction. And we're going to give it a starting point by turning our ortho on, having our snap on, choosing a desired vertex, and then we'll go down in the Z direction that we desire, and we can just give it a nominal thickness of 0.1. Now we have these as 3D solids and they have thickness. What we'll do is we will union those to create a single object. You can see that if we hit delete, that now is a single object that we can export, and we're going to export that as a STL file that you can print for your roof. It's desirable to make a copy of this just from a base point, and what this allows us to do is create 3D solids that we can combine to give you the height that you desire for the volume of your roof. Work it out as a single enclosed space, because at the moment it'll only work out the volume of this shape. So we know we've got a 2x2 shape reference from our -1 to 1. So you can go and draw by hitting Shift 2, 2, rectangle. What that allows us to do is to extrude this at a height that we desire. We can then extrude actually we can't do that. You need to go back a little bit. What we should have done is we should have kept this as a 3D mesh and extruded it from there as our 3mm going down. So we'll just go and revert. We'll just move this out of the way. We'll go through and we'll import the mesh again. Do the same process. We will select it. We'll do a 3D P thicken. Normal size. We'll explode this so that we can extrude. And then we'll do a direction again, and this time we'll do a nominal direction of, say, 3mm down, which gives us a nice solid that we can work with. Now we'll do a union on that solid, well, bunch of solids, so we get a single shape. And we'll just move that slightly out of the way so that we're not interfering with the other one. Now we should be able to make a solid that we can extrude, and we might make this, say, one, knowing that we've got the height that we want. So we'll copy this across, move it, sorry, to a selection that will allow us to interact. And that's not going to give me the size I want, so I might have to make another one. You'll have to work out the height that you need. Part of the scale and the sizes that you're working with. So again, I'll make this, say, 2mm. And I'll just move this across. Now I can create a single shape where I can then use the height that I need. So I'm going to put a union towards those. And I have a single object. And again, I'll make another box. can extrude this. And I'll move this box across. I'll move it from the bottom corner. Now I can do a subtract, and I can subtract from this object. Now if you can't see it, change it to your wireframe. I'm going to subtract from my original object this object, where this can be calculated out as the height you would desire for your roof. We've just got a slight little bit of missing vertices there. But if we type in mass prop, select our object, it will give us our mass and volume. Now this is only a scaled version, so we know this is 2 by 2, and if we wanted our roof to be, say, in meters, we can go and scale our object. We can do both at once if we desire. We'll just do one. Choose a base size, and if we want it to be meters, I'll just scale it by 1,000. So I'll do the same thing here. And they're slightly overlapping, so I'll just move those away from each other. Now if I do my mass prop, select my object, this will be in millimeters as my volume, mass volume being the same, we don't have a density to it. There's other parts you can look at with moments of inertia, etc. But this value here is what you should be able to derive using your calculus for your Z value, the function of your X and Y. To make this your 3D object for printing, you need to select it, choose the A, go Export, Other Formats, and we will change ours to a STL file. And we'll just call it, say, Roof 3D. We go into our Maker bot print, we'll go New Project. We'll insert a file and we'll navigate to the file that we desire. And again, that might be the wrong scale to print from. So we will scale this down by, say, 10%. And then we will go to our Arrange and Place. Again, still looks a little bit large. So we might scale that down by, say, 5% and place that. And that starts to look reasonable. Not a bad sort of size for us. If you need to rotate it, you can go around your X, Y, Z, etc. Then we're going to click on Export, and it will then build this as a MakerBot file. We'll go through the process of exporting that as a file to a USB, and then we can navigate through our File Explorer, and we can go and get the file that we desire and go to our 3D printer, and then we can print it.